Which of the following will not reduce the heating effects of eddy currents? We have a few options: lamination, using ferrites in the iron core, using cooling fans on the transformer, or increasing the number of coils in the transformer. So if we look at C, that looks a little bit suspicious, right? Using cooling fans on the transformer won't actually reduce any of the eddy currents. However, it will reduce the heating effects of the eddy currents because it will cool the whole transformer down. In fact, our correct answer here is the last one, D. This option means that because we have more coils, we'll in fact probably get more eddy currents than if we had less. Question 5. When a force is applied to an object, how will the torque behave? Will we get the greatest torque when the force is parallel to the line of the object? Will we have a greater torque when it's far away from the axis of rotation? Will we have a torque produced only if the object is in a magnetic field? Or will the torque be produced that will oppose the force that created it? So all of these sort of have elements of what we know about torque. So let's just quickly think about what torque is. If we have, say, a wrench turning a bolt, classic example of torque, then in order to turn it, we need to produce a torque, and we can get the greatest torque when we push down perpendicular to the wrench, far away from the axis. So if we were to push parallel to the line of the object, that is this way, there's no way that we could get the wrench to turn, right? So in fact, when the force is parallel to the line of the object, the torque is 0. The torque is not produced if the object is in a magnetic field. That applies for motors, sure, but in the case of any other torque, we'll be getting a torque without a magnetic field. Finally, the torque does not oppose the force. The torque is a result of the force. So our proper answer is B. The torque produced is greatest when we apply the force furthest away from the axis of rotation. And intuitively, we can see that in the example of the wrench. This, of course, is also the reason that doors have a handle that's away from their hinge as opposed to close to their hinge. If the handle is far away from the hinge, then we can produce more torque and open the door more easily. Question 6. If two nearby parallel wires are both carrying a current, the force in each wire is attractive, repulsive, 0, or cannot be determined. So let's think about this a bit. We know that our equation for the repulsion of two wires is F over L equals I1, I2 over D. So that means that if they're both negative, the force will be repulsive. If one's negative and the other is positive, then the force will be attractive. And if they're both negative, then the force will be repulsive. But it means that if we don't know the polarity or the sign of each wire, we won't actually be able to tell the direction. We can tell right away that it's not 0, but it's impossible to tell whether the wires will attract each other or repel each other, which means that our answer here is D. The force has a direction which cannot be determined without knowing which directions the currents are flowing in.